Hello and welcome to PreCalc. Today is Monday, November the 30th, and our topic for today is systems of linear equations. Linear because we're only dealing with straight lines, and system because it's more than one equation. Each set has two equations. So as you probably remember, there are two main methods for solving these. We can solve by elimination or by substitution. We are going to select which method to use based on whichever is most efficient and most convenient. So let's look at our first question and decide if we should use elimination or substitution. I see that this 8 matches up nicely to the 16, where if I multiply the 8 by 2, it'll match the 16 and they'll be able to cancel. So for our first example, I'm going to use the elimination method. So we're going to multiply this whole second equation by 2. This equation did not change. The second equation is now negative 16x minus 12y equals 12. Remember that the 2 needs to distribute to each term. Okay, now we're basically just going to add these guys together. 16 plus negative 16, 0. The x's are canceled. That's what we wanted. Negative 10y minus 12y is negative 22y. And then 10 plus 12 is 22. I'm going to solve for y by dividing both sides by negative 22. 22 over negative 22 is negative 1. Okay, so we know that y is negative 1, and we're going to plug back into this first equation to find out what x is. You could plug into either equation. I just happen to choose the first one. So we've got 16x minus 10. We know that y is negative 1, so we're going to replace y with negative 1 equals 10. Okay, 16x negative 10 times negative 1 is positive 10 equals 10. Take away 10 from both sides. 16x equals 0. Divide both sides by 16. And 0 over 16 is 0. So we know that y is negative 1 and that x is 0. Let's finally write our answer as a coordinate pair, as an x comma y. That must be 0 comma negative 1. This is also the point at which these two lines intersect. So we have solved algebraically for the point of intersection. Because if we know the x value and we know the y value, then we know the point. Great. Let's consider our next example. Make sure you pause and write the original problem. Okay. Over here, I see a 5 and a 3, a 1, a 6. Nothing lines up that nice, so elimination will not be so helpful here. What's going to help us more is our substitution method. I also see that y is by itself right here, telling me it's going to be easy to find out what y is and substitute. So when we're substituting, we want to get one variable by itself and then plug that in to the other equation. I'm going to rewrite this. I'm choosing this one because y is already has a coefficient of 1. All we need to do is get it by itself, and we don't need to divide anything. Okay, so to get y by itself, I just got to add the 5x over to both sides. So I have y equals 5x minus 2. All right. Now we're going to take this and plug it in to our other equation right here. So instead of y, we are going to write 5x minus 2. So we still have the negative 3x plus 6 times. We know that y is the same as 5x minus 2. We showed that right here. So instead of y, we're going to write 5x minus 2, and it still equals negative 12. So negative 3x, distribute the 6, and I've got plus 30x minus 12 equals negative 12. Negative 3x plus 30x is 27x minus 12 equals negative 12. We're going to add this 12 to both sides. Negative 12 plus 12 is 0. Divide both sides by 27. 0 over 27 is 0. Okay, so we know what x is. Let's plug that back in right here to find out our value for y. So y equals 5 times 0, because x became 0, minus 2. 5 times 0 is 0. 0 minus 2 is negative 2. Okay, so we can write it as an xy point now. Coordinate pairs are xy. We know x is 0. We know y is negative 2. This is also the point of intersection where these two lines here meet. So the solution is the point of intersection. Alrighty, that's all for today, guys. Thanks.